All right, Algebra 2, moving on, still in Chapter 8. We are in Lesson 8.7, and we are finding rational roots. So remember, rational numbers are still real numbers. They're just real numbers that could be fractions or decimals. So we're using the rational root theorem to find those. Our essential question is, can you find rational roots of polynomial equations with integral coefficients? Suppose that a polynomial equation with integral coefficients has the root h over k, where h and k are relatively prime integers. Then h must be a factor of the constant term of the polynomial, and k must be a factor of the coefficient of the highest degree. That's a lot of wording in which we need to understand what we're doing. So the first question, I have some keywords just like always. My first question says list all the possible. So I tell my students, put possible, we're going to put our p's over our q's. And what that means is that if I take all my p's and all my q's, I'm taking the factors. Well, there aren't many factors of 1. I know plus or minus 1 is a factor of 1. But it's going to be over the q's, and there's a couple factors of 4. Plus or minus 1, plus or minus 2, plus or minus 4. So the possibles are p's over q's, and now I'm going to go ahead and put them together. So my answer, I have to put it all together. Plus or minus 1, plus or minus 1/2, plus or minus 1/4. So notice there are 6 possible numbers that will be the rational roots of 4x to the 4th plus 3x squared minus 1. So our next question is going to say, well, if the equation in number 1 has 1 or more rational roots, solve it completely. So what I need to do is I need to take this and use what we call synthetic division, and I'm going to put the numbers over here. Well, you know what, I'm going to write it over here. It was 4x cubed plus 3x minus 1 equals 0, and my possibles are 1, 1/2, and 1/4. And now I can go ahead and blow it up and show you what we have to do with this. So, all right, so we're going to put all of our synthetic division. I had a couple of the numbers wrong. Did you notice that? I just fixed it. But now we're going to put our synthetic division to use. So I'm going to use a positive 1 first. And I'm going to use all these numbers across. 4, 0, 3, 0, -1. And when using synthetic division, I know something's a factor if 0 is the remainder. Add down, multiply up, add down, multiply up, add down, multiply up, add down, multiply up. That's not working for us. So let's try -1. I could do -1 up here. I have 4, 0, because I have to mark the x cubed spot. I have 3, 0, because I have to mark the x spot, and -1. Let's get down to business. 4, multiply up, add down, multiply up, add down, multiply up, add down, multiply up. It doesn't look like -1 is going to work as well. So let's try 1/2. Positive 1/2 with the numbers 4, 0, 3, 0, -1. I know I want 0 to be the remainder. Let's give this one a shot. 4, half of 4 is 2. Add down. Half of 2 is 1. Add down. Half of 4 is 2. Add down. Half of 2 is 1. Hey, we got a winner. So we know that 1/2 is going to be 1. So I'm just going to circle that right now. And let's try negative 1/2. I have 4, 0, 3, 0, negative 1. And remember, I want 0 to be the solution. Drop it. Half of 4, negative half would be negative 2. Add down. Half is 1. Add down. Negative half of 4 is negative 2. Add down. Negative half of negative 2 is positive 1. So it looks like negative 1/2 is also a solution. So let's keep checking. I have a few more to check. I just have 1/4. I know this is tedious, isn't it? I have 1/4 and negative 1/4 to check. 4, 0, 3, 0, negative 1. Drop it. Multiply. Add down. Multiply. Well, that's ugly, isn't it? Don't you love when they give us ugly? 3 1/4. Multiply 3 1/4 times 1/4. You know what? I'm going to put this into an improper fraction. That way, 13 quarters, because this would be 12 over 4, right? Plus 1 over 4. There we go. And that gives us 13 over 16. Add down. Yeah, this one isn't working for sure. And let's try that negative 1/4. Oops, I was moving my paper. Negative 1/4. We have 4, 0, 3, 0, negative 1. We want this to be a 0. 4. Negative 1/4 times 4 is negative 1. Add down. And now we get 1 1/4, which is 5 quarters. Add down. We get negative 17 over 16 when we multiply and add down. Yeah, I don't think this one's working either. So what this is saying is that when I put this equation, I'm going to highlight it for you. When I put this equation into my calculator, 4x to the 4th plus 3x squared minus 1, I have two roots. My first root was 1/2. My second root was negative 1/2. And when I put this in the calculator, I should be able to see those 2 points being marked on the x-axis. So I know if this is 1, they're going to go through here. And the parabola should look something like that, where it's actually going through those 2 points. That's what it means when something is a root or a solution or a 0 or an x-intercept. So remember my steps. I had to find the possible roots first, use synthetic division with all those possible roots to see which ones actually worked, and then I could tell you the roots, the actual roots for this polynomial.